going to finish this little section up. If you kind of leave it just a little bit, I'm sure I'm going to have a rush of kids in within the next 6 minutes. Thank you. That's good. Thank you. First period, it's quieter in the halls. All right, we're going to build our confidence interval for your variance and your standard deviation. Now, if you remember way back when we first did variance and standard deviation, we did a table. Now, in that table, we found your variance. We took the square root, and it became your standard deviation. So we're going to do the same thing with your confidence interval. We're going to find your variance, then we're going to take the square root of the whole thing and find your standard deviation one. Now, this looks really scary, but yesterday we found these guys. This is your degrees of freedom, and S is either your sample standard deviation or S squared, your sample variance. So it's really not that bad to build this once we have all the pieces. So we're going to take a look at this. It's really not that bad. The only bad part is there's no calculator step. So again, when we do this, we're going to identify your degrees of freedom. We're going to find your point estimate, whether it's variance or this is your sample variance. Or S is your sample standard deviation. This is the guy we find in your calculator. And then we put it in your formula, and then we square it. So this is more likely what you're going to find. We find your critical values like we did yesterday off your table, and I gave you table 6. Those of you that walked in, here's table 6. Anybody else? No. We're going to find your critical values. We're going to build your confidence interval. This is your confidence interval when we build it. Now, I want you to notice the right and the left. You found your right and your left when we did this. We said the left one was the smaller one. The right one was the larger one, because that makes sense to us. When we do the confidence interval, we have to put the larger one on the left-hand side, because when you divide a number, say this is 8, if I divide this by 2 and I divide this by 4, I get this. It's not what I want. I want the smaller number to be here. So I've got to divide the larger number on the left-hand side and the smaller number on the right-hand side. It makes it mathematically correct. It builds your interval for you. So we're going to see that in another minute. Once we get all of that in there, we take the square root of this guy, because the square root of your variance gives you your standard deviation. And again, we find how confident we will be that your population standard deviation will fall between these two numbers, these two values. It's the same kind of setup. We just have to build this as we go. It's really not that bad. There's not a lot to it. So let's try one. I'm on page 315. You randomly select and weigh 30 samples. This is your N. Page 315. You assume that the weights are normally distributed. They need to tell us that. And the sample standard deviation. Here's a piece of your information. Your N is 30. Your sample standard deviation is 1.20. You want a 99% confidence interval for this, for the variance and the standard deviation. Now, the first thing we're going to do is set this up so that we find a left one and we find a right one, just like we did yesterday. So we look for your degrees of freedom. What's your degrees of freedom? 29. Don't worry about it. I can grab one of these sheets there. That's your table 6. Okay. 29. Anybody remember how we looked this up? Anybody remember those little formulas that we would use? 1 plus c over 2, 1 minus c over 2. This is the guy that you always used in inverse norm. Do you remember doing inverse norm and you would say 1 minus 0.99 divided by 2? Remember that? If you remember doing inverse norm, just do this one. Remember to do this one. 1 minus 0.99, you're just looking at it as a fraction instead of written out. So this is going to give you 0.01. When you divide it by 2, you get 0.005. This is the only one you have to do. Because how do you find the other one? Subtract from 1. So the other one has to be, 995. 0.995. It doesn't like this today. So 0.995. Now, I printed you out your table 6. We're going to find your table 6, find your degrees of freedom, 29. Come across, remember this is symmetric across the top. 0.005, 0.995. The smaller number goes on the left-hand side. So pull out your two numbers. Degrees of freedom 29, 0.995, 0.005. Your chart's symmetric, so they're right along the edges, both of them. So what's the smaller one? The left one. Good. 13.121. And what's the right side? Yes.
So for most of the time, it's just going to be these on each side. Like it's not going to be.
It's exactly symmetric.
Okay.
So, like if you did this one, this is going to give you the 0.995. But you only have to really remember one of them. So the easiest one to remember is the same one that you do for inverse norm. And this part is its complement, 1 minus this.
But is it always going to be like, is it always going to be like this side is like, if you have 2 points, is it normally going to be like the left side is smaller, this one will always be smaller than the other one?
Yeah, just like if you could watch the way the numbers
Will
go.
you ever have one where you like, it will be like,
No.
like one will be...
No, if you watch the way like in the line of numbers, it's always smaller to large.
So you'll always know, like this one will
The
always,
left.
the left side will always be the left one.
It is the left number. That's a good way to remember it. Left side, left number. Yeah. You'll notice it as soon as you put it on your graph because your graph has to go from 0 to infinity.
Will it ever be like in the middle, like how it goes from 0.995 to 90 and then from 10?
It'll do the 90 and the 10.
Oh, okay.
The 90 and the 10 does it because anything's symmetric. If you took the middle of your table and drew a line down it, it's symmetric across the middle. So if it's a 90, it's a 10. They have to add up to 1. If it's a 95, it's a 0.05. Okay, now, your formula says degrees of freedom, which we know, standard deviation squared over your x2, and this time we're going to put the larger number here, so this is your r. Okay, this is my r1. We're going to do the variance side. God bless you. God bless you. God bless you.
Thank you, sir.
No, that's all right. So now,
Well, because no one was up front, I was alone.
Victoria was there. Okay, so easy formula, and I give you this formula, so you don't have to worry about it. There's not a lot of information that they give us when they deal with variance and standard deviation. We don't have a mean, we don't need a mean, so they don't really bother giving us the mean. They do have to give us something about the sample, either the variance or the sample standard deviation. Bless you. Now here's the most important part. S squared is a variance. S is your standard deviation. So if you plug in your standard deviation, you're going to have to square it. If you plugged in your variance, that would be S squared. So your variance doesn't get squared, but your sample standard deviation does. See what I'm saying? Okay. This says S squared. S squared is your variance. If they give you the sample standard deviation like now, we're going to square it. if they gave us the sample variance, that is S squared. Then we don't square it. So we're going to take this information and plug this in. This is your degrees of freedom. My degrees of freedom is 29 times my standard deviation is 1.2 squared over my larger number, 52.236. I do the same thing to the side. Notice that both numerators are exactly the same. 1.2, that's a 1.2. And put the smaller number on this side. If you had chance put the bless you, switch the bottom, switch the denominators, you'll notice it when you build your confidence interval, and you just have to switch those two values around. Because your confidence interval says the smaller, less than, this, less than the larger. Now, all you have to do is put this in your calculator just like you read this. 29 times 1.2 squared divided by 52.236. So you put it right like this into your calculator, and you get, I'm going to put it over here, 0.80318. Yes.
Should it be 0.8? No.
It's 0.8, yes. Thank you. A little too small on that one, huh? Less than this. Now, that's a 3.18, but my board is a little bit off here. This is your confidence interval for your variance. To find your confidence interval for your standard deviation, this is the variance one. All you have to do is take the square roots of everything. So you take the square root of this. This now gives you the standard deviation interval. Okay, so you take the square root and you get 0.89 and 1.78. Okay, this is your confidence interval for your standard deviation. So most of the work is finding those two little values that we found yesterday. They're only really giving you your sample size and either your standard deviation or your variance. And then we're just plugging that into the formula. Make sense? Yes.
How is this square root of 0.89?
Because if you take a number less than 1 and take the square root, it's actually larger. That is true. Like if you took the square root of 0.25, which is 1/4, it's 0.5. It's 1. Square root of 1/4. Think about it. Do it in a fraction. It's actually 1/2. Anything less than 1, oh, I'm sorry. Thank you. Anything less than 1 comes out greater. That was a good observation. Okay, so again, we're going to find the critical values. Thank you. Find the critical values, set it up, and find your confidence interval for your variance, your confidence interval for your standard deviation. So you guys, well actually let's do this next one together. I wish I could save this and move this, but we'll just move this down. They now want us to find one for 99. I just got to reset my board. Change. You have the same formula, but what's going to change? The left and the right values. Good. So we need to find an x2r and we need to find an x2l. The sample size stays the same, the standard deviation stays the same, and your degrees of freedom stay the same. What's going to change is your x2r, your x2l. We're still going to use the same formula, so the numerator stays exactly the same. This is your x2r, this is your x2l. Your numerator didn't change. The only thing that changed was your two values. So for your 90%, let's look up an x2r and an x2l. I'm going to use the 1 minus c over 2, because this is the one we normally use. 1 minus 0.90. This will give us your 0.10 divided by 2 is your 0.05. What's the other one? 0.95. Good. This one is 1 minus c over 2 again. So 1 minus 0.95 gives us 0.05. Oops. Sorry. This is 0.025. And the other one, 0.975. Everybody see what we're doing here? We're looking up your two values. Those are the only two values that change. So you guys set me up the confidence intervals for these based on the information that we have here. The numerators are not changing. Give me a 90 and a 95. Take a minute. The numerators are exactly the same for both of these guys. Degrees of freedom, standard deviation squared. What did you get for your R value, your right side value?
40.557.
Okay. And your left side value?
17.79.
Good. So this comes down to 0.981 and 2.358. This is your confidence interval for your variance. You're going to be 90% confident that your population variance falls between 0.981 and 0.2358. Okay, to find your standard deviation one, just take the square root of everything. And this would come out to be 990.536. And again, go 3 decimal points on these guys. Go 3 decimal points. Good? So, for our 90, we're gonna put this all on a number line as soon as we're done. For our 95, we keep the same numerator again. All we do is change your bottom number based on these two now, and degrees of freedom of 29. So you should get 45.722 and 16.047. 0.913. This is your variance. Take the square root, and this is your standard deviation confidence interval. Now, if we put this on one number line, I'm going to start with your smallest one, 0.99 and 0.1536. Let's then go to your next one, your 95. See, it's just a little bit, I lost my place. 0.99, 0.956. Something's wrong here. Okay, something's wrong. We're good. Sorry. So 0.95 and 16, 13. I know they're not evenly spaced apart, but you can still see where your confidence interval goes. And then a 99. 0.89 and 1.78. So do you kind of see how they got wider as you needed to be more confident? Right? It follows the same with all your confidence intervals. The higher the confidence level, the wider the interval is. Right? Are you guys comfortable with this? It's not hard. It's unfortunate there's no calculator for this,